All right, now I'll start. I'll see if this works. If it doesn't, whatever. Okay, so taking out a constant. So integration day 2, consider the following. You can take out the constant of an integral, but can you take out the variable? So the first one, can I take out the constant? Yes, I can. I can rewrite this as 5 integral x dx. Okay? So yes, I can take out that constant. What about the variable itself? Can I factor that out of the... No, of course not. So it's got to stay as integral of x dx. So no, unfortunately, you can't take out the variable. Otherwise, you're getting rid of the entire question. Now, let's have some kind of review as using the chain rule, right? So when I'm doing the chain rule, and I'm going to be using my u notation. So I make u the inside. I have the derivative of u to the power of 20. And when I have the derivative of u to the power of 20, I drop the exponent down. I get u to the power of 19. Am I done? What do I have to multiply by? Right. So times u prime, right? And then you could go ahead and you could go and solve that, replace your u with x, right? Go back through. I'm not going to do that. Second one, if I did this one, again, I would replace everything inside the brackets. I would have d by dx of u to the power of 20. Same thing, I would drop the exponent down, u to the power of 19, but again, I'd have to multiply by the u prime. This is what I'm trying to get at, is that you have to multiply by u prime. Okay? And then again, you could figure out what u prime is, substitute it back in, and solve. Last one, again, same thing. You have d dx times u to the power of 20 equals 20 u 19 u prime. In each case, u prime is different. Every u prime in that is different, right? Because it's all based upon the inside of the brackets. Again, you could go and solve for that if you wanted to. So that's integration using the chain rule using u notation, right? Using u notation. Now what we're going to do is we're going to be doing integration using the chain rule. And we're going to do this the first time. We're going to do it the Mr. Howell way. So this is the way that I do it. Mr. Epp and I do things a little bit differently. I'll show you the way he does it as well. The first way I'm going to go through it, I'm going to do the Mr. Howell way, right? Because I'm Mr. Howell and it's my way. I don't know, whatever. So I'll keep going. All right. So what it says there is it says, okay, I need to use u notation. When I'm doing the u notation, this is extremely important. This is brand new. We have to do some let statements. And my let statements go something like this. Let u equal. And I'm going to let u equal x squared plus 1. What's inside the brackets? I'm going to let u equal what's inside the brackets. A pickup line. Yeah. Wow, you guys are really creative. Let u be. Okay. All right. So what would du be? Whenever I do this u substitution with integration, I have to let u equal something, and then I have to let du equal something. Well, what is du going to be? Du is the derivative of u, which is what? 2x, right? 2x dx. Okay? So that when I go up here and I integrate, I'm actually integrating. Now I replace x squared plus 1 with u. And the exponent on u is 2. And I have du. But if I'm solving for, if I'm replacing dx, right? If I'm replacing this dx, I have to look at this dx down here, and I would say, well, dx is actually equal to du over 2x. So I'd have du over 2x. Okay? So you're replacing dx, you're substituting dx with du over 2x. Okay? Because if I go down here and I have du equals 2x dx, and I solve for dx, I basically divide by 2x. to get it on the bottom. 2x on the bottom. I don't have very much space here. Pardon? Better? Better? Yes, now I have more room. Thank you, Lucas. Excellent. All right, let u equal. Again, I'm going to let u equal what's inside the brackets, which is x squared plus 1. We're finished at as much as we can do. These ones are just to kind of explore, what do I do with the du? What do I replace? No. No, you can't. You'll see why. These examples are just to show you, well, what do I replace du with? What do I replace the u with? Okay? Or what do I put u with? Sorry? You'll see. Yes. Is which? Over 2x. That's a 2x. 2x. All right, so du for this one is going to be 2x. Again, 2x dx. So again, I could solve for dx. I could say dx is actually equal to du over 2x again. So this ends up being the integral of u to the power of 20 times du over 2x this time, right? Now, this next example will illustrate exactly why we were doing this, because people don't seem to understand what the heck is going on here. Now, I'm going to do the same thing. Let u. Every time you do these, you have to put let u equals, and you have to find du. Again, this is a good reason to go over it as well. So I let u equal, again, x squared plus 1, which means du is going to be equal to 2x again, dx, which means dx is equal to du over 2x. Du over 2x. I've done that. Thanks. All right. So this ends up being the square or the integral of u to the power of 20. But I have a 2x here. This is important. The 2x stays there. 2x. And then I have du over 2x. Notice anything? Okay. So look what cancels, right? I can cancel off that 2x with that 2x. And now I have the integral of u to the power of 20 just du. Now I can actually integrate it. These ones up at the top, you cannot do. You cannot integrate them. Because I have a stupid 2x there. It's stuck there. These ones, when I cancel it off, now I can finally integrate it. I'll show you in a second. So, question 4 there. Again, the same thing. I would let u equal x to the power of 3 plus 4. So du is equal to 3x squared, right? Which means, and that's 3x squared dx, which means that dx would be equal to du over 3x. This is the Mr. Howell way. This is the way that kind of shows you what cancels. That's why I'm doing it this way. I'm not going to do it this way every single time. 3x squared. And that is equal to the integral of u to the power of 15, 3x squared times du over 3x squared. Again, notice that the 3x squareds cancel, which leaves you with the integral of u to the power of 15 du again, which is good. Now the x's are gone. Everything is in terms of u. Okay? How could you write the formula you're using? Compare. Well, what happens when I'm doing x to the power of n over dx is I have x to the power of n plus 1 over n plus 1 plus c. Okay? So instead of subtracting, you know how you drop the exponent and then you subtracted 1 from the exponent? Drop the exponent when you're differentiating. Now I'm going to be increasing the exponent by 1 and dividing by that new exponent. So instead of multiplying by the exponent and then subtracting 1, I'm adding 1 and dividing. Opposite. Right? It's exactly opposite. So if I have the integral of u to the power of n du, what happens here? Well, I'm going to have to take the integral of u to the power of n times it by du, and I'm going to have to kind of take like a u prime, right? Every time I do this, I take du, which is the same as u prime. Is that clear? That was essentially what I was doing up above, is I'm taking du over u prime. This is both our way. Yeah. This is exactly how you kind of do it. So what does the du mean? Well, the du means that I'm going to integrate, if it's in an integral sign, I'm going to integrate with respect to, that's with respect to u. Du, just like dx, means and when you're doing dx, like d over dx, it says differentiate with respect to x. This time, integrate with respect to u. Okay? Integrate with respect to u. So I need everything in terms of u. Yes? Yes, essentially they're exactly the same thing. This one here I can actually do because I don't have a u. This one here I'll have to change it to a u first, then I have to do the integral, then I have to remember to divide by the u prime. You'll see how it kind of works when I go through a bunch of specific examples, because these are so general, right? It just basically means when I'm dealing with the u, I have to make sure that I'm substituting it in, and I have to make the u equal something, and I have to find du. I have to solve for the u prime, right? It'll become way more clear once I go through some examples. All right, again, we are going to do this the Mr. Howell way. Just to make clear who I am, we'll put the glasses on me, we'll put the smiley face, we'll put the big beard. This is what I used to look like back before I started teaching. Nobody cared what I looked, well, except for my wife, but that's okay, she didn't care. So, but there's the Mr. Howell way, right? This is me. So again, this is the way that I do it. I put the dx, or I put the du, and then I solve for dx to show me what cancels. Okay? I'll do the Mr. F way after. I'm okay. I'm okay with Mr. F's way too. So, let's look at these. Well, I have to figure out what I need to let u equal. This is the toughest part of these. I have to say, well, what am I going to let u equal? Because when I divide by my du, right, when I divide by my u prime, something has to cancel. Otherwise, I can't integrate it. So what am I going to let u equal? Sine x. Sine x. Okay? Because du is going to be equal to what? Cos x. Right? Dx, which means that dx is going to be replaced with du over cos x. No, because I'm differentiating. Sine cubed. So when I'm replacing this with u, sine cubed x, u is just sine x. So what's it going to be? U cubed. Yes. But you have to make u whatever, you have to make u something so that it will cancel. You have to make u something so that when you take the derivative of it, it'll cancel. Because now I have du over cos x. Oh, the cos x's cancel, right? Because the cos x's cancel, I'm left with just u cubed du. What's the integral of u cubed? Integrate it. So I increase the exponent by 1 and I put it over that new exponent plus c. Right? This is all stuff from the That's right. Now you have to replace u with what you had before. So that's actually equal to sine to the fourth now, x over 4 plus c, and you're done. Okay? But don't forget to replace it with what it is. Replace it with the x term after.
So is there more like specific way of finding which doesn't equal it, or are you looking inside?
Most of the time it's the thing that's in brackets, or it's the thing that's kind of more complex, usually. Generally the thing inside brackets. So for this one here, what do you think you're going to let u equal? Yeah. So you're going to let u equal. Yes. No? Yes. This just means when I have the integral of u cubed du, just means do the integral of u cubed. Du tells me what my variable is. My variable is u. All right. So I let u equal x cubed plus 1, which means du is going to be equal to what? Yeah. 3x squared dx, which means that dx is equal to du over 3x squared, which is good because I can see up above that that's probably going to cancel, right? So that means that's the integral of 3x squared times the square root of u du over 3x squared, and the 3x squareds cancel. If I made u equal to which one, right? If I let u equal 3x squared, then du is going to be 6x, which doesn't cancel with anything. And then I'm still left with this x cubed plus 1 underneath the square root. So then I have a complex x underneath the square root that I can't get at, and nothing cancels. Or the only thing that would cancel, no, nothing would cancel. You have to have that cancel, that 3x squared. And it leaves it as something simple, right? I have the square root of basically u to the power of a half du, which is like an easy integral to do. What's that integral? Right, so basically 2/3 u to the 3/2 plus c. Okay? So it makes it really simple. And then, oh, I haven't finished yet. I forgot to replace my u with what it was. So 2/3 bracket, u was x cubed plus 1 bracket to the 3/2 plus c. That should be my final answer. Okay? Don't forget to replace your u with x. All right, number 7. So what I'm going to let u equal this time? Which one? Yeah, inside the brackets, right? That's a big hint. X cubed minus 2. So my du is equal to? Yep, 3x squared. So what does that mean, my dx? Dx is equal to then, drop the exponent, over 3x squared. So this becomes the integral of u to the power of 5 times x squared times du over 3x squared. Okay? What do you think I could do with the 3 on the bottom? Because I know that the x squareds cancel, but what about the 3? Yeah, make it 1/3 and put it out front. Exactly. So this is going to be 1/3 now times the integral of u to the power of 5 du. Okay, and that's a big hint. Notice that the number you can just pull out front, right? Those coefficients you can just get rid of. And then I solve this. I get 1/3 times, what's the integral of u5? Yeah, so u6 over 6 plus c. Again, replace it. So I get 1 over 18. And u was x cubed minus 2, all to the power of 6 plus c. Good? Yeah, because I had a 1/3 here, and then I have a u6 over 6, so 3 times 6 is 18. Yeah, just, yeah, put the numbers together, the coefficients together. All right, next one. Number 8, we're going to let u equal, again, what's inside the brackets, right? It's the easiest thing to do. X to the 4th minus 1. Because then I know that du is going to be 4x cubed dx. So dx is going to be replaced with du over 4x cubed. So that becomes the integral of u to the power of 5, x cubed. Dx is replaced with du over 4x cubed. And again, the whole point of these is to cancel things out, right? And what do I do with the 4 on the bottom again? Yeah, put it out front. X cubes are gone. The 4 jumps out in front. So this ends up being 1/4 times the integral of u to the 5th du, which is 1/4. Again, I get u to the 6th over 6 plus c. So what's the fraction out in front then? Yeah. So the fraction out in front is 1 over 24. I can replace u with what it was, which was x to the power of 4 minus 1, power 6 plus c. Okay, last two on this page. And then once I'm done these last two, then the next page will be the last page I do. Yes. And I will do the next page with Mr. Epps' way. I'll show you how he can. I mean, it's very similar. All right, this one, what do I let u equal? What do you think? Somebody? Yeah, so x to the 4 minus 1. So what's du? 4x cubed dx, good. So that means dx is going to be du over that, over 4x cubed. So I replace this, get the integral of u to the 5th, du over 4x exactly. And we saw that right from the beginning. If the things don't cancel, you can't do them. Yeah, Lucas? Yeah, kind of. Not really, though. I mean, they're always going to cancel. If you can't do them, you'll see right away. But most of the time they cancel. They're nice. I mean, that's how they kind of work, right? You have to be able to cancel, and so they're set up like that. It's like when you're learning how to factor trinomials. They set them up so they actually factor. Kind of like that kind of stuff, right? But sometimes it is difficult to figure out what do I make u. It's not always easy. All right, last one here. We're going to let u equal what? Now I got two options. Yeah. Again, always pick most of the time, always pick the inside. So du is 20x cubed. The minus 1 goes away. Dx. So that means that dx is going to be du over 20x cubed. Integral of u cubed times 7x cubed du over 20x cubed. This time, what is the coefficient going to be? Good. So it's going to be 7 over 20, right? Because I have the 7 and I have the 20. And that's going to be pulled out in front times the integral of u cubed du. So my 7 over 20 stays. Inside I have u to the 4th over 4. So what's the fraction I have out in front then? Yeah, 7 over 80. I'm going to replace u with what it actually is. So it's 5x to the 4th minus 1, all to the power of 4 plus c. Pardon? That's good. This stuff's kind of fun. It's more algebra based, right? So you don't have to, yeah. All right, I'm going to do the second page just to finish it off before we do the trig. And also I'll do this the Mr. Ep way. And this will go a bit quicker. Because you guys have already seen now why things cancel, that's why I kind of showed it to you. Okay? And here's Mr. Ep, just so you don't get confused between me and Mr. Ep, right? Is he a happy guy? Yeah. He's got some hair. So there's Mr. Ep. All right. This is how I'm going to kind of do it with him. So, same stuff applies. You still have to do your let u statements. Nothing else has really changed that much. It's not going to be, you won't see that much difference. So u is still x squared plus 5. You still make it what's inside, what's in the brackets, or things like that, right? So du is equal to 2x dx. Basically, this way I'm not going to put the dx in. I'm just going to look and say, okay, I know that the x's cancel. Okay? Because this whole term, the 2x and the 3x, the x's match. Look to see what matches. That's what cancels. You just have to keep in mind what the coefficient is going to be. And what is the coefficient going to be outside the integral? Right, 3 over 2. So just make sure that you understand that that's dividing by 2 and the 3 gets pulled out. So this ends up being 3 over 2 times the integral, that should be a 2, times the integral of u to the 1/2 du. So you guys understand how things cancel. I'm not going to replace it with a dx anymore. I'm going to do it the fast way, right? And that's 3/2 times what? U to the, good, 3/2, all plus c, cancel, cancel, because they're both reciprocal. And I'm left with just x squared plus 5, all to the 3/2 plus c. No, that's a good point. No. Yeah, the c is always on its own. You never have to worry about multiplying the c. You never have to worry about multiplying the c by the value, ever. Okay, the c is on its own. Eventually with these things, you do have to solve for c. Eventually when you get these are called indefinite integrals. You do definite integrals, then you have to solve for c, so it does get complicated, but always leave the c on its own. Okay. All right. Next one. Let u equal what? Yes, 2x plus 1. So du is equal to just 2. This time I don't really have anything that needs to cancel, right? You just have to worry about your coefficient in front, which is what? Right. So again, 3 over 2 integral of u to the power of 5 du. That one's simple. You get 3 over 2 bracket u6 over 6 plus c, and then just replace u. 3/12, 2x plus 1, 6 plus c. I mean, simplify these as much as you can, right? As much as you can. So I would put that to like 1/4. All right. Now they start getting a little more interesting because now we're dealing with rational expressions, right? What's your guess for u, though? Yeah, the bottom, right? So it's going to be x squared plus 2x plus 4. The more complex one that you make x, the simpler it becomes when you take the derivative, right? The simpler it becomes. So does it become what? What's the derivative? Can you do anything with that? Yep. take out a 2, so I'm left with x plus 1. Okay? That's the thing that matches with the top, so that's the thing that cancels. That becomes the integral of. What's on top of the fraction? Which? X plus 1 is gone, though, because it cancels with this here. 1 over 2. Where are you getting 2 from? Good. So 1 over u cubed du. Okay? I could rewrite that if I wanted to u to the negative 3 du. You don't... Oh, sorry. 1/2. Yeah, sorry. That's what you're trying to say, Lucas, right? So 1/2. 1/2 becomes 1/2 bracket. I get u to the negative 2 over negative 2. That can be rewritten as negative 1 over 4. U was x squared plus 2x plus 4 to the power of 2, and it goes on the bottom of the fraction because I have a negative exponent. Plus c. All right. Next one. Now we start dealing with trig. Right? We start dealing with trig. So, you're still going to have stuff cancel. You got cos to the power of 5x and sine x. So what do you think you're going to make u? Well, let's make it, I think cos x works out better because cos is the more kind of complex one. But we're not going to let it equal cos to the power of 5x. We're just going to make it equal cos x. You could do cos 5x, but it would take, I think it's a little bit more difficult. So du is equal to what? Negative sine x dx. So you see what cancels? The sine x and the sine x cancel. What's my coefficient in front? Negative 1. Just a negative 1. What am I left with here? Yes, good. So u to the power of 5 du. Excellent. So that's an easy one. You just get negative. U becomes cos to the power of 6x over what? 6. I'm just skipping the step where I do the u to the power of 6 over 6. I'm substituting it right away. Good so far? Any questions? No? All right. Almost done here. So number 15. Again, we got a complex trig. We got two things being multiplied. So what am I going to let u equal? 10x. Because what happens when I take the derivative of 10? Exactly. Okay? So that's how you kind of figure it out. You're like, okay, well, which one do I pick? Think about what the derivative would be before you pick, and then you can kind of see what cancels, right? Secant squared x matches that one, so it's gone. Am I left with a coefficient this time? No, nothing. So it's just the integral of u du, which is just u squared over 2 plus c, which is just tan squared x over 2. Last one. What do you think you want to let u equal this time? What's your pick? Good. So 1 plus, I'll make that x to the power of 1/2. Okay? Everything that's inside the brackets. So what's du equal to? Sorry? Yeah. Right. 1/2 x to the negative 1/2. Which is the same as 1 over 2 root x, right? So because this is over root x this time, you can see, okay, that's over root x, that's over root x. Those are the things that cancel. But what does my coefficient become this time? Yeah, so 1 over 1/2, which is just 2. Good. Because it's always that flipped. It's always the coefficient flipped, right? Yes. If they're both on the bottom, they cancel. If they're both on the top, they cancel. That whole thing becomes u to the power of 4, because that's what I let it equal. And then it's just a simple integration. 2 u to the 5th over 5 plus c, which is just 2/5. And you have 1 plus root x all to the power of 5 plus c.